So the continuation of the previous topic, that is interplay of classes and objects. Next, on building quality classes and objects. So while building classes and objects compulsory, we require some quality. So say this system should be built with a minimum set of unchangeable parts. So if you design a system, compulsory some parts are going to be unchangeable. Okay, so those parts should be general as possible. So that parts should be a general normal ones. For example, if you create a class, compulsory a class keyword, class name, data members, data types, these are general things. So these are the common things, so that are not unchangeable. Okay, while creating a class or an object, whatever it is, some point of some minimum set of objects or whatever it is not unchangeable. Okay, so that should be represented as general or as general, that should be represented as general. So and all parts of the system should be held in uniform framework. So if you create a class or else if you create an object, compulsory all the parts are going to be uniform, they work uniformly. Okay, so while building a class or an object, compulsory some points should be general. Okay, and all the parts regarding to the class or else object should be work uniformly framework. Okay, with the object oriented development, these parts are the classes and objects that make up the key abstraction of the system, and the framework is provided by its mechanisms. So above what I am saying is some parts we have to declare it as general. So general is nothing but abstraction only. Okay, after that all are working uniformly means nothing but the mechanisms. Okay, so the design of classes and objects is an incremental and iterative process. Okay, it's a repeated process and is going to be incremented. So if you increment only, then only iteration possible. Okay, for example, if you take a loop, for loop I is equal to 1, I1, I less than n, I plus I, whatever it is, there increment is there as well as iteration also there. Okay, so measuring the quality of an abstraction, so we have 5 points are there for measuring an abstraction. Okay, coupling, cohesion, sufficiency, completeness, primitiveness. So see this, the first topic is coupling. So how much relationship contain an object and class, how much the relationship is there, the measure of the strength of the association established by the connection from one module to another module. So at what strength, the strength of the association established with the connection between one module to another module, that is the measure degree of the accessibility, how much we have to access them. Here in cohesion we have coupling, we have to identify the degree of accessibility, what is the amount, what amount of accessibility there for accessing a module. Okay, so for that purpose we have to identify the relationship, how much strength is how much strength of relationship is there between between modules. Okay, if the coupling is very harder, okay, if the coupling is very strong, then accessibility becomes difficult. Okay, that's why weak coupled classes are desirable. So if you have a weak coupling, okay, if you have weak coupling, then accessibility become very easy, nothing but if you have interrelated with one module to another module, if the coupling is very strong, then the accessibility becomes very very difficult. Why? Because all are interrelated very strongly. Okay, but if you have a weak couple, then there is a possibility to access the module, or access the classes, or access the objects, whatever it is. So if you have a weak coupling, accessibility becomes very easy. Okay, next coming to the cohesion. So in this cohesion measures the degree of connectivity among the elements of a single class or an object. Okay, so here we have to identify the degree of connectivity, how much connectivity there. So the least desirable form of a cohesion is coincidental cohesion, in which entirely unrelated abstractions are thrown into same class or module. So first in that cohesion, first thing is coincidental. Coincidental cohesion means in which entirely unrelated abstractions are thrown into some same class. Okay, in coincidental class, unrelated abstractions are taken and throw that into a same class, okay, or a module. So the most desirable form of cohesion is functional cohesion. In this the elements of a class or a module all work together to provide some well bounded behavior. Okay, so to provide in cohesion, if we have a coincidental cohesion, there we have to identify the unrelated abstractions. Okay, after in that it is a main important thing, that is a functional cohesion, means in which we have to work together to provide some well bounded behavior. So for getting best results, we have to use functional cohesion. Okay, so in functional cohesion all are related to each other, and it provide best results. But in previous coincidental cohesion it not possible, because their unrelated abstractions are there. That's why functional cohesion is better when compared to the coincidental cohesion. It gives better results. Okay, next coming to sufficiency. So in that, by sufficient we mean that the class or a module captures the enough characteristics of the abstraction to permit meaningful and efficient instruction. So see the sufficiency. So by meaning itself we can understand what is the sufficiency. Okay, so for implementing a problem domain, some requirements are sufficient. Okay, for getting efficient interaction, so some meaningful, some permit characteristics are required. Okay, that is going to be enough for getting problem domain, for getting solution for the problem domain. Okay, sufficiency means enough. Okay, for example, if you are designing the class set, it is wise to include an operation that removes an item from the set, but our wisdom is futile if we neglect an operation that adds an item. So generally, for getting a problem, for getting some problem, we require sometimes for if a class contains add, subtraction, multiplication, so the operations are there, but we required only add operation only. So by using add operation only, we have to perform addition operation. So there is no need to require subtraction, multiplication. Okay, so in sufficiency what they are saying means, whatever the requirements we have for getting for getting solution for the problem domain, that is going to be enough for getting solution. Okay, after the completeness. So by complete we mean that interface of the class or a module captures all the meaningful characteristics of the abstraction. So completeness means we have to complete a clear cut idea and clear cut solution for regarding to the problem domain. So completeness means we have to get a meaningful solution. Okay. A complete class or a module is thus one whose interface is general enough to be commonly usable to any client. Okay. Means in completeness based on the client. So here client is the final product accepted person. Okay. Whatever the requirements, whatever the specifications they specified, like client, so we have to fulfill that requirements and specifications. Okay, that means we have to complete the product we have to give to client. Okay, next, primitiveness. So in primitiveness, the primitive operations are those that can be efficiently implemented only if given access to the underlying representation of the abstraction. So, in primitive operations are those that can be efficiently implemented only if the given access of the underlying representation of the abstraction. So, see this example. Adding an item is to a set is primitive because the implementation of this operation, primitive is nothing but basic. So for implementing add operation, compulsory we require add method. Okay, so we have to represent, we have to show, we have to visible that add operation. For implementation purpose, compulsory we have to visible, we have to know the inside view. Okay, primitiveness is means for performing particular task, the basic needs. Okay, so like just now I told you that example. For implementing add operation, compulsory we require add method. Okay, next, choosing operations.